Okay, so chapter 33. We'll go over the TCP/IP, the network OSI models again. We'll do a really tiny example that is also part of the book, how we can connect to a server using a client application. And then, so we do this client-server application example that's also in part of the book. And this is another part that is kind of good to use because you can actually get the information about the user or the server or the client, where they're coming from, what IP address they use, and so on. If you were to write like some type of application that would track user information, okay? And we'll also talk about a little bit about the threads and multi-threading. So we'll give a little bit review on that, and then we'll talk a little bit more next week. So first things first. Back to this, IP, right? Internet protocol. We had the IPv4, IPv6. We know what those are, right? So IPv4 is, becoming obsolete, and then now it's being replaced by IPv6. I'm not sure when. It's still in the process of converging. A lot of companies are still kind of hesitant to switch to IPv6 because the cost of doing that. But eventually we're going to be moving to all IPv6 only because of the number of IPs we can have now versus just 4 point something billion IPs. Okay, so I don't think we have to review that part here. We'll talk about the TCP and the UDP here. These are two different protocols. These are also part of the OSI model, right? If you remember, TCP is what's called a connection-oriented protocol that's always guarantees a reliable connection between two systems. Okay, and these are used like in emails, chats, video chats. Any type of transaction that is live or requires a reliable delivery, that you use TCP. Like when you make bank transactions or payments, all those are considered TCP because they need to be reliable. The UDP is the user datagram. These are not reliable because you don't need to, right? So for example, live streaming and video streaming are the two most popular types of, and also in radio and podcasting too. These are usually UDP because you don't need to guarantee the delivery. So maybe as you deliver data through the internet, some of the little packets might be lost. They might not come through. So that's what you might have a little choppy videos, or maybe in the audio might have a few words or a few tiny piece of data cut out from the audio stream, and that is still fine, right? Because people usually we don't care. So that is the UDP. It's for a connectionless protocol. That means it doesn't have to confirm that whether or not the system is connected, right? It doesn't care. It just say, okay, I'm using UDP. I'm going to project all my data out to all the receivers. Who wants it, get it. If you don't, I don't care. Okay, that's UDP. But for the TCP, you need to have it's like a handshake type of process. So it's like you make a phone call to somebody, right? If you want to talk to somebody, if you want to talk to Jason, I need to, what do you need to know, right? You need to know his phone number, and so that'll be like the IP address. If I know your phone number, I can call you, and if you're not able to answer, then you can't confirm it, then I can't talk to you, so therefore that connection cannot be established. But he's there, he picks it up, and then I call him, he say, hey, this is Jason, and then he confirms it, and then now we can start talking, right? So that's TCP. Okay. Email is part of that because when you send an email to somebody, and if that email is a fake email, then you will get a message saying, oh, it was not delivered, right? So therefore the connection was not made, even though it was not live at the time when you were there. So that's requires a TCP connection. And Java supports both of those communications, okay, TCP, UDP, which is, again, these are very common types of protocols for communication across the network, the internet. So back to the OSI model here. If you remember, all right, from your other class, if you haven't taken it, then one day you will. So these are the 7 layers here. The TCP/IP layer is right here. So they have the transport layer. This is the layer that is responsible for connection between your system. So it's layer 4 here. Okay. Let me just do this. So it goes down this way, top to bottom to the physical layer. It goes out to the other system, and then it will go in the reverse direction up this way. But layer 4 is responsible for making that connection between 2 systems, either through UDP or TCP. Okay. So just a little bit review on this networking model here. And the networking classes, that means there is a class, or there are some classes in Java that uses for the purpose of networking. Again, networking just basically communicating over the communication between 2 systems, 2 or more systems, I should say. But really, you just require 2 systems. Okay. So the superclass is the java.net, which is for network, right? For the Java is the super, the IO is actually the super of all that. But anyways, java.net is a superclass of all the subclasses. So you have different subclasses here for to serve different purposes. So we have the TCP on this side, which uses the URL connection, socket, and ServerSocket. So these are the ones that you'll be will be doing in this examples and also in your homework assignment. And then on the UDP side, you have these 3 major classes that you can use to transport or to deliver data from one server to the next server. Okay. So this is just some major differences between the 2 here. Again, it's just reiterating that requires a dedicated point-to-point channel between the server, the client and the server. So if there's no connection between the 2, then you cannot establish that communication, and therefore data cannot be transferred. Okay. Whereas on the other side, over here, you don't really need that connection there. So what that means is that data may not be delivered, and so if something that you don't really care about, whether or not the client or the server receives any type of confirmation, then you will use UDP. Otherwise, I use the TCP. Okay. Again, this means the same thing, right? Dedicated, lossless, and reliable. I mean, data cannot be lost. If it's gets lost somewhere, if it's a tiny piece of data, one of the packets gets lost, then it will be retransmitted, right? Until everything gets to the other side, and then it will start to display your information. So when you receive, you build a web page, you load an image to the browser. So you can imagine what happens if you use a UDP for that purpose, right? You have an image that has missing pieces, and that doesn't look good. So that's why sometimes you see that a browser takes a really long time to load some data, because it needs to establish that connection, and it needs to wait until all the data packets come through in order to put it together, right? So that's why it's lagging sometimes. Okay, so it's same thing here again. It just says you need a connection. So for the UDP, contents are not guaranteed, whereas the TCP, communication occurs between the client and the server must be reliable, right? You have to have the connection. So then we have the client-server communications. So there are actually 2 types of communications. The client to server, and you also have the client-to-client communication. And they're both popular. The client to server will be like if you're a client and you want to get some type of data from a server, then this is the client server. A very common type is, of course, when you do on your web browser. When you request a domain name or you look for a site, you are a client and your computer is the client, so you're actually communicating with the server. So the server's job is basically to provide a response. That's all it does, right? It provides response and based on the request. So that's an example already of what a client-server communication is like, right? But with Java and most other applications too, other languages, you can write your own client-server programs. And so you could have you can write a server application that will respond and provide certain type of data to any user for that very purpose. And so if they know your port number and know your domain name and so on, then they can communicate with your server, and the request that they request can be sent out by your program. Okay, this is also really a good example would be like if you remember Ajax, how Ajax works. Okay, kind of similar, same thing here. But on the client side, then to build this type of application in Java, you need to have two programs. So two Java file minimum. One is to provide the server side for the ServerSocket, and you need the other one for the client side. Okay, so in order for them to talk, so it's a socket here. It's a so you have a ServerSocket class, and you also have another called socket class, right, for the client. So this is for the server, that's for the client. Okay, those two different classes kind of give you a hint there. So a socket really then is just an endpoint. Okay, it's an endpoint that allows the communication to occur. Okay, and if you look at this diagram here, okay, so you have like the server side, this top blue box, versus the client down here. So what happens is that the server needs to start that server socket. Okay, it needs to be activated first. If it's not on, then of course the client cannot make any communication with that server, and so therefore cannot establish that communication. So when you run your program, you would write your server code, and once that's done, then you need to run it. Okay, so while it's running, and then you can run the client-side application, and so the client-side will try to make a connection to the server through this socket here. Okay. Again, the client needs to know the socket that the server is using. So, for example, let's just say because on the server side, you can create your server to have many ports, right? So this port, let's just say this server here uses the port number. Common one is 8000, for example. Then the client application needs to know that, okay, this server here has a port, uses a port 8000, and so therefore when it creates this new socket here, this object has to know the socket number, okay, as well as the IP address of the server where this is being located, because a server can be anywhere in the world, right? It's just a website, kind of like a web server somewhere. So if you know the IP address, then you can connect to that server. But to really run and interact with the server, you need to have the port number. So that's why on the web page, a web server, the port is always available is port 80. Okay, so port 80 is very commonly used for web pages. So that every website you browse, then when you search on the Google or any browser, it automatically knows that it's looking for port number 80 on any web server. Okay, so if you don't have a port 80 on your web server, then therefore it cannot be reached and it will not work. Okay, so that is default port already. It's reserved. And so that by the same token, you can do the same thing. So you build your server, you will give it a port number, okay, a unique port number, and then that port number will be used for any client application. And then once that communication has been established, so the server can accept, okay, or it can decline your request, depending on how you code it, right? You could say that I only accept users coming from a certain IP address. If the user comes from a different IP address or out of the country or out of the area, I do not allow connection, right? You have that option there. so you can accept or deny the socket, the communication there. Okay, and if it does accept the communication, then it will go into this communication process. This cycle here, you have the read and write cycle. So if you notice, both of these servers have the read and write. Okay, so because they need to communicate with each other. So what that means that the server needs also to write data to the client, and so the client needs to read it or receive the data, whatever that is, and at the same time also need to send data to the server as well. So they both have read and write privileges here. Otherwise, there's no way of communicating. It's just a one-way communication, and that may or may not be useful. So you have, so you usually occurs in this cycle here is when all the communication takes place. So when you log into a website, you go to google.com, it accepts your request, which is the port number 80. You go in there and it allows you to browse their page, and then you can start searching, right? You send a request to look for a car, it will search the data, and then once it finds it, then it will send the data to your browser. Your browser reads it, displays it, and then it will wait here until you make more requests. When you make a request, you're actually writing some data to, and then send that over to the server side. Okay, so you go through this cycle here until you log out or you close the browser, right? Same idea here. So once either the browser is closed on your side or on the server side, if the server is turned off, then you lose the connection. Okay, so this is a typical cycle when you do a connection or a communication over these two programs. So on the server side, for example, if you were to write this as a program, you will write this server application and put this on your machine or on your web server or anywhere on your server. And then at the same time, you will write another application and you will use that as a client. And then you can pass this around or post it on the internet or sell it to other people, and they can use it. And then this application, because you wrote the code, it would know what port number to communicate with, and so on. So when you buy, a certain type of application or app, this is usually what happens behind the scene. You may not know it, but it has a port number that connects to the main server, and so it can retrieve data back and forth between that main server and the app or that software. Okay, and then of course, because wherever this application is installed, you can also track the IP address of that the user or the owner of that app, and that's why you can have the option of accepting or deleting or denying the communication here. Okay, so this is the overall, I guess, a high-level overview of what the Java socket looks like. I wouldn't say just Java. Most of the networking are working similar in this way. Okay, so on the client side, client server, for example, a client requests a service. Okay, so it requests any type of service. Look for, ask for a date, ask for some data, or hey, can you process this data for me? That's a request. So that's called a service via a port number. Okay, so on the client side, if you look on the one on the right here, this is the client application, and so when you write the code, you have something like the class socket, and then the socket here is just the object name. It could be anything, and then new socket and the server host. Okay, the server host is the host of the server side. Okay, so whatever that host is, so this would be like the IP address of this server here. So if you're writing this in your local laptop or your machine, it'll be just localhost. Okay, so localhost, or maybe 127.0.0.1, right? That's the localhost IP address. And then you need to know the port number assigned to this host here. So when you write the server host side, you need to give it a name. The port number. Here you assign. So when you create this socket here, you give it a port number 8000, and this 8000 needs to be given to the client side so they'll know, so they can match the port number. If the port number doesn't match, you cannot make the connection. It's like if I don't know your, it's like I know your IP address, But if I don't know your extension, then like you make a phone call, I don't know your extension, I cannot reach you. Okay, kind of same idea. And once that's been established, then you can have a communication between the two.
Is it, if you've got a HTTPS SSL certificate,
Mm-hmm.
change any of this? Is that like another layer that you have?
Yeah, that's another layer on the HTTP protocol. Yeah, so that would be like going from the unsecured to the secure layer. So on the browser or on the server side, you have another layer of communication between the two. Right. Okay. So this part, I mean, of course, you can have it so that because when we talk about communication here, you have two kinds. One is the Java web services. We have the other one is called the Java RESTful communication, which is going through the internet. And then this is not going through the web browser, but going through just the network, the internet. Well, it is still going to internet, but it's not going through the HTTP protocol. So when you talk about HTTPS, that's another separate layer that is on top of this. Okay.
We don't have to worry about it.
No. Yeah. Well, I mean, yeah, the HTTPS, that's another completely separate protocol that you would have to. I'm not sure if you ever owned this website before, but to do that, you have to get a certificate from an issuer, and then you would have your own key. Then you have to match the key with your site and so on. So that does it automatically on that end. Okay, so then once the connection has been accepted, then communication takes place. Okay, so the server establishment, when you create that connection, the server, that socket, again on the server side, you will create the socket, and then you also give it a port number. So any port number between, I wouldn't say 0, but it's usually between 1024 or above, and that's ideal. Okay, the reason is because anything below this and anything between here are pretty much reserved. So I would say that anything between 0 and 1024 are reserved for other services. So when you build your application, you shouldn't use those port numbers. Use something big, like greater than 1024, like 2000 or 8000, for example. Okay. Some ports here, maybe you already know some of these ports, right? These are reserved. And usually these are built into the protocol so that you don't have to worry about. But you know, like FTP, SSH, Telnet. I forgot what this one is. SNTP, DNS. Okay, 480 here is for the web, right? And the email is the POP3, and then secure server HTTPS is 443, and so on. So these are common ports. These are many, many more, up to 1024, right? Those are reserved. I've just showed you here some common ports.
I know there's an Xbox one.
Oh.
For Microsoft.
Oh yeah.
It's a dedicated port.
Yeah. Right. Yeah. There's for that. There's one for SQL Server databases. You know, the 433 or something, 434. I forgot what it is. So yes, you have about 1024 of those ports are reserved. Okay, so here's an example. When you create a socket on the server side, then you would do this code, ServerSocket class, give the socket name, and then new socket and give port number. Okay, 8000, let's just say the port number you're using for that. But also notice that if you're using port 8000, and if you happen to have like Tomcat using the same port number, then you have a conflict, right? So when that happens, you want to change it to a different port. So that's also something you want to also be a little bit careful of. And if that port is not allowed, it's already in use, then you have an error. You'll just say port is not available or cannot communicate. After a socket is created, then the server uses the following list to listen to it. So you write this line, create a new socket. Next line is just you issue that, and you wait for the the connection from the servers from the client side. Okay, that's why it says a socket is like for client socket. You're waiting for to accept any communication coming from the client side. Okay, and then as soon as so it's on a waiting state all the time. So as soon as the client side it makes that communication, then it will accept it or deny it based on how you code it, and then you establish communication. And then on the client side, you would do something similar, except you use the socket instead of the server socket. Okay, socket, give it a name, and a new socket, and then you need to know the IP address and also the port number that you need to connect it to. Right. So in the example here, we use port 80, and let's say the IP address is this, and this is actually the one the IP address in the book, which is also the author's IP address for his site on the university. But you can change it to any IP address you want. It could be your local host here, or the 10.27.0.1, or any IP address you want to connect it to. If you know the port number on any site, any domain, you can connect it to. And usually port 80 is open, and also port 13 is also open, right? Port 13 is so up here just give you like the time, local time of day for that server, so you can connect to that port, and then you can find out what the port is in the world, wherever that is, and get the local time. Okay. So once you create that new socket for the client side, and then again, if the host is not found, I mean the IP address doesn't exist, then you have another error. It just says unknown host exception. So usually when you do a socket, it's a new socket here, it will ask you to throw or cast the throwable exception. Okay, so here's an example that you can make a connection to, for example, on the National Institute of Standards and Technology, NIST.gov site. They happen to have several IP addresses. One of them is this one here. Okay, and if you know the IP address of any site, you can connect it to, and here I'm just showing you they can connect to the port 3013. And if it's connected successfully, then you can say you can put a message here saying it's connected, right? Otherwise, you have a message saying you cannot connect. Okay, so that's maybe we'll test this in a bit here. Let's see if that works. But as long as you have internet, connection, I think it should work. It's it's available to the public. So, and this site has a lot of IP addresses you can use in different locations. The one I'm using is, I think it's in Maryland. So if you want to find out the time zone there, have a different time. One's in Colorado, one is in different multiple locations, and any other places here too. These are in like different regions. Okay, so you can hook up to those sites. And then once you have the communication established, then you can start transmitting data through those sockets. So communication is just like, again, if you think about this, it's just like you have two functions or two programs that talk with each other in the Java application. Some students, some people get a little bit overwhelmed by sockets and networking, but really if you think about just two functions that's sending data over to each other, then that's all it is, right? The only thing between this and the what's the other one called? The HTTP, the RESTful for the web services. There's another chapter of web services which we don't have time to go over, but it's very similar. The web services, you would do the same thing. It's also communication between two systems. Okay, whereas this sockets or this networking is you actually sending data to a different server or system, and that system receives your data, and then you send another data back, right? You don't know what's inside the other server, so it's completely black box. All you know is that, okay, I have a port number, I know your port number, I know your IP address, here's the data, I need you to process this and send it back to me. Okay, it does that for you, right? Whereas on a web service or the web services, you can actually access the other server's functions or methods inside its own server, and you can call those functions to do certain things for you. Okay, you still don't see what's inside, but you can access those methods. So if you have a function to calculate, for example, factorial, you can reach out to the other server and call that function called get factorial, or assume that they gave you those information. Okay, whereas this one you can't call. You cannot call to a client or another server machine and call one of these functions in there. You can't do it, right? So all you can do is just send the data or the packet to the socket, and you're at that server's mercy to whether or not send you the information back. Okay. So here again, back to the example here is also in the book. Going to show you again that now we see the code a little bit in details. Okay, they look very similar in the in and out part here, as you can see. This part here and this part here looks exactly the same. Okay, well, almost, yeah. It is same because you're reading and writing data back and forth. If you remember this diagram up here, I showed you earlier, right? It's within here. It's this cycle here. So the read and write is same. So I can write data to the server, and I can also read data from the server. So the server does the same thing, write data to the client and then read data from the client. Okay, so that part is the same. That's why you see in the code here, it looks very similar in nature. So server side, you get a port number. You need to establish the in and out for sending and then receiving data from into the client. And then you have a server socket and also a socket for the client to communicate with the client. Then you just code it this way, and accept here just waiting for the communication. As soon as you run the application on the other side here, you establish this a new socket, the host and the port number. Right there, it will communicate with the server side. Okay, once that's been processed, been validated, and the host match, the port number matches, then you establish that communication. And then once that's done, then data can flow. Okay, and then you can start sending data to and back into the server and so on. So again, basically you open a socket, open the input stream and output stream to the socket, and then you read and write data according to the protocol. And then you close it and you close the socket. As soon as you're done reading or writing, you should close them. If you don't, you're going to leave it open, and then you have consume a lot of resources. So when you build those two applications, again, you should start the server side first, right? Okay, that's the one that is waiting for that communication. It's waiting to process the data or whatever the request is, and then the client is the one that actually making a request. So you run that second. And if you run in the wrong direction, then this communication cannot be established. So just make sure that you run the server side first. So here again, the kind of same stuff here. So the client, so this is the one in the book also about coding or getting the radius from the server, and then the server will send some data back to the client. So the client side requests the server to process some data, and then the server is responsible for sending the data back to the client, right? So here is like, okay, you would send a radius or any number to the server, and server will process it and get the area of that radius and then send it back to your client. So if you look at this, you'll see that when you make the connection from the client side, the server side will receive that number. For example, if you pass in 4.5, you click enter, then that 4.5 gets sent over to the server side. Server received it, you output that message here so you can see it, and then you would then calculate the area and then send the area back to the client, and the client will receive that 63 whatever it is from the server side, and then you will display that, and then you send another radius over, and you get this whole communication back and forth between the two. Okay, so this one here is just the client server, meaning that the server does not it doesn't do anything other than just responding to your request. Okay, if you were to have a client-client type of communication, then this is like a chatting program, a chat program. You can chat from, this is you, this is your other person here, so you can chat between the two. Here you're just going in one direction. You just requesting data from this side, and then it processes it and sends it back. Okay, here we put the data so we can see it, but if you don't put any data here, then basically you just receive the information from the server like this here. Okay, so that's how this is how client and server work, right? It's responding to requests. Same thing here, kind of similar. Notice that though, when you send a request over to the server side, right? The server side, when you make this socket, you have to give it a port number, 8000. And when you send it from the client side, client needs to know that port number 8000 so it can send that over. When you do that though, on the client side, the code, the Java JVM automatically assign a port number to your socket as well. Because we didn't assign it, it'll be automatically assigned to it so that it knows where to come back to. Okay, and that information will also be sent over to the other side so they know the communication. So which means that you can have multiple sockets on this side. You can have like 3 or 4 different applications here that are connecting to the same port number on the server side, and the server will know which data to send to which port number, right? Because each socket, each client has its own port number, okay, and its own IP address too. So that's important. I mean, we don't assign it, but it's assigned automatically in the code, in the program. Thread. This is, I think more information is in chapter 32 or 31. I don't remember which one it is. But a thread is basically, it's just a sequence of instructions. I wish it's a sequence, but it's a thread of instruction that run in a program. When you execute something, then you want to create a thread, what's called a thread. That thread is a little program that runs within a processor, okay, or a process. And these threads are sometimes called lightweight processes. Okay, well, a process, if you look at this, is if you think process as a CPU, right, in the computer, then you can think that each CPU is a process. If you think about it that way, then within the process you can have a lot of threads inside. So it's like tiny processors that would do its own task in there. Okay, and in the old days when we didn't have multiple core or processors, you have only like a single processor. Then it kind of you have some limitation because you have only one processor can only do certain things at one time, and you have to share the processor to process a lot of data until we have the multi-processor and you have the multi-threading techniques now that we can have multiple executions can occur at the same time concurrently inside a process. Okay, so when you build your socket applications, network applications, that's why you will have to spawn a thread to make that connection between your program and the client side. So you have a thread going on there. So if you have another client connects to the server, that generates another thread, and you can have a lot of threads going on at the same time. So therefore your server can still communicate with all these different threads or all these different clients sockets, right? If you think about like you make a phone call to another person, and if there's no call waiting or things like that, then you have a one-to-one communication, right? Just one thread. But with the multi-threading is that you can allow multiple people to connect to your phone, and you can have like a conference call, right? So each person can dial to your phone number, and you can allow conference calls, so you can have multiple threads. So each of those calls is a thread. Okay.
Is this like when you're putting stuff in your programming, it's like asynchronous?
Yeah, yeah, asynchronous or synchronous. Yes, you can make them either way.
Wait, yeah.
Mm-hmm. And so asynchronous means that you can run it any time you want. It doesn't matter. Synchronous means you make it both run at the same time. Okay. And that depends on how you want to do it. This is like, for example, would be like you want to process a lot of data. When we talk about big data, let's say millions and millions of records. So what you do is that instead of having one program runs entire 100 million records of data, you would break it down into processors or threads, so that thread 1 can process the first million, second thread process the second million, and so on. So they do those concurrently at the same time. Okay, and you can make those synchronous. So that means they would do at the same time, and each will be done at the same time. Hopefully, maybe some will be done earlier than others. You can do that, or you can do asynchronously. I mean, you can do any time. Just as long as thread 1 does the first million, it does its job, and then the other thread is doing the other million, and so forth. So you have maybe like 1,000 threads running all these million data. So that way you will run the data much faster that way. Okay, and this is also part of what's called a parallel programming. It's the same thing. So if you imagine like in animation or like movie studios, they build all these cool CGs, right? They would take maybe hundreds or maybe thousands of hours just to render a animation like Avatar. Okay, it requires a lot of CPU time, and imagine you have only one single CPU to do all of that. Okay, it would never be completed in I don't know how many years. So instead of that, you have a lot of processors, and they will use all those processors at the same time to render each piece at a time. So once those pieces are rendered, then you can put them together, and you have your character made. So same thing here. Okay, so just a little bit different discussion between a thread and a process. So a process, if you think of a process, it's a much bigger application that runs a certain task, and then inside the process you can have threads inside it to run smaller tasks. Okay, and so that way you can have a process that runs a lot of threads in there. So when you buy a computer that has, today we like very standard have 4 core or 4 CPUs. So you have the quad cores, right? And the computer can have more than that too. So the more cores you have, the more processors you have, then usually the faster they run when you run your applications. But again, that depends on the program itself. If they built a program to use those processors to run in parallel, then that's fine. If they don't, then you just it's the same thing as using a single processor. Okay, so what that means is that a server can serve multiple clients at the same time, and so you can have chatting and video chats and so on. So here you can have thread 1, 2, and 3, and then do their own task at their own time, and then when they're completed, then you can wait until all the threads are done, or you can process data as soon as thread 1 is done. You can process it and keep going. Okay, I'm going to stop here and we'll take a break, and we'll come back, and then I will finish it off here, and we'll do a few examples, and we'll run some examples on the client and server, and then I think we should be done for today. So see you back in about 10.